Today we are going to solve lead code 69 Sqrt square root of x. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You must not use any built-in exponent function or operator. Like he is asking us to find the square root of a particular number. If we don't have the perfect square, we need to return the rounded answer. Like here, as we all know that we have the square root for 9, but we don't have for the 8. So the square root of 8 is 2.8 something, but we don't want this float value, so we will be returning only a rounded value, which is 2. And if we see like what is meant by rounding of his particular value, like if we have 2.1 something, we'll round to some fixed number which is below, like 2. If we have 1.8, we will round up that 1.8 to 1. So like if we see the problem, like by seeing the problem only we will be getting some ideas like what is best square root. A perfect square will be if output, if we multiply the output into output, we'll be getting the x, right? If like mostly if it is not perfect square, let's see the approach, other approach. Like my approach is like going from 0 to till x plus 1, like 5, and checking each and every element whether it is a perfect number or not. Like you can see here, from I in range to 0 to x plus 1, and I will check each and every number whether it is a perfect square or not. If it is not perfect square, I will be returning the least the the index where the I into I is greater than x, which is written I minus 1. So like we solved using like for loop, normal linear search, right? But this will take square root of n. What is square root of n? Like how we got this square root of n means, mostly everyone will say that the time complexity of this algorithm or program is big of n. But if you see deeply, you will be seeing return I. When will be the I? Like if we have written in any code, you should not see this. You should see this. Like when this algorithm will be stopping. I star I is greater than x. I star I means I square, right? If we transfer the I square to the other side, we will be getting root of x. So that's how we got the square root of n. Like why we'll choose the return I minus as the end case means, even if it is I square into I is equal to I square is equal to x, we will do square, transfer the square root to the other side, but we will not go toward the end of the array. Got it? So like we solved using normal brute force approach. Let's solve using our favorite method, that is binary search. So like how we'll be going to solve means, same basic idea. Let's take s is equal to from 1. S is equal to, you can take from s is equal to 1 or 2. Like let's go with 0. Why? Because if we take 0 here, you will be not having this less than to return x something. That is also good only, but if you take this thing, you have to use one here. So like what is our approach means, we'll just this is a common template as we saw in the previous videos. So like we will check if the middle element is equal to x, we will return the middle element at the spot. If it is not, we will check whether the middle element is greater than the x. But my idea is to check the greater than x. But how he solved means, he solved using lesser than x, and he still uh, goes like he is moving s is equal to mid plus 1, and then this is the common step. Like if we use this step here, this step is common. So like what's the why is used if mid star mid lesser than x. Do you have any idea behind like mid star mid is lesser than x means? He's actually finding if we don't have the perfect square, we will be returning the next next number which is lesser than the x, right? So like he's checking if mid star mid is lesser than x, we will store the answer in the mid. And as you all know that the we are iterating from 1 to 4, right? If for example let's take 4 like 1 comma 2 comma 3 comma 4, like here uh, he got the if let's imagine the mid is at the 2, like he will check 2 star 2 is lesser is equal to x, so return mid. That's true, but if the mid is at 1, 1 star 1 is lesser than x, x means 4, right? So like he is just moving the s. Like we can find any other index which is satisfying this condition. That's the why he used this condition. I hope you understand. So let's run this code and check whether it's runs properly or not. I already run this code, but let's see if it has any issues with it. We can modify it. Yeah.